today we're looking at this picture here of a very large angle, the yellow here. I want you to have a look at these two questions. So pause the video and have a think about these two questions. How many degrees does this look like? And how might you describe this angle? So pause the video and have a go at that question. Okay, so I'm hoping that you've been starting to look at this angle and recognise it sort of being as a half the turn. So if you have a look around, if we moved that round, you can see it's kind of half of a circle shape, and it's along a straight line. So it might give you a lot of clues about how many degrees there are in this angle. Another thing that might give you a helping tip is if I add in an additional line here, you should be able to see two further angles on this straight line. So you've got one here and one here. And the way I've represented it should give you an indication about the degrees in that angle, because this is our right angle here. And hopefully you've remembered from your previous learning in the school that that is 90 degrees. Okay, so both sides of that vertical line are 90 degrees because you've got your right angle in the corner there. Okay, and if you are quick at calculating, you will see straight away that with our 90-degree angle here and our further 90-degree angle, this whole angle here, this whole yellow angle, will be the sum total of 90 and 90, which is 180 degrees. So the degrees that we can see, so I'll put it up here so you can see the answer to this question, is that it is 180 degrees. Now, some of you will be familiar with this piece of equipment. Here we have a protractor. We have them in class quite a bit, and you might have had a chance to use these before, particularly when you're measuring angles lower down in the junior school. Now, I can then use this piece of equipment to prove that there are 180 degrees in my angle along my straight line. So if I put this protractor along the straight line, you can see here we start at the 0 here and work our way all around the edge. We can get to 180 degrees, and that shows us that that's how big our angle is. So it's 180 degrees, two 90-degree angles at right angles added together. So now we've thought about year 6, how many degrees there are along the straight line, we need to work out how we can describe this angle. Now, we will be going into reminding you about this when we return to school next week, but hopefully this is a refresh for you of some of the work you would have been already doing in the junior school when you've been talking about and describing angles. So I'm just going to take you to this website here, which will help to demonstrate to you the different type of angles that can be described. Okay, so here you can see we've got all of these types of angles that we can describe. We have an acute angle, a right angle, an obtuse angle, a straight angle, a reflex angle, and a full rotation. Okay, so as you can see by this description below, an acute angle is less than 90 degrees, and we'll touch on this knowledge a little bit later on in your learning. But just to remind you, like the letter A, capital letter A forms that acute angle, and it is less than 90 degrees. It's like R cubed, I always think. Really nice. It's a really small angle. And you've got your right angle, which is exactly 90 degrees, and you will be familiar with looking for right angles within your work and in the classroom, probably when you were in year 3 and year 2. An obtuse angle is anything that is greater than 90 degrees, but less than 180 degrees. So those are things that we are looking at that are between this 90-degree angle and that 180-degree straight line angle, which is what we've got on our demonstration, which we'll come back to in a moment. And a reflex angle is an angle that is greater than 180 degrees, so anything past 180 becomes reflex. You can see it as I'm doing that on the diagram there. And then obviously you've got your full rotation being 360 degrees, which will really help you with your learning for tomorrow's lesson. So just a reminder of those things so you can have that in your fingertips. Here goes, it's under their website mathsisfun.com and under the section called angles. It's got quite a nice little picture summary here of all the different names for the different angles and what they are called. So you can see that, and just be careful with what you're labeling, because you might be looking at the angle here between these two yellow lines, or the angle around here between the yellow lines. And both of these angles have different names. The smaller angle is our obtuse angle in this case, and the larger one being the reflex angle. So with that knowledge in mind, you should already be thinking, well, I can describe this angle as a straight line. If we go back to that website and look back up, we've got our straight angle, which is exactly 180 degrees. So we're looking at our straight angle there. So that's how we would describe this angle, and that will help us remember the very key piece of information that we need to take forward, that this is 180 degrees. And hopefully that will help you with all the calculations and all the things that you need to do to solve the missing angle problems today. You have got several angles given to you, but still one mystery one to find out. So some people label that with a question mark, can label that A, to help us know that this is our missing angle that we need to identify. Now, straight away, you should remember what the total degrees are along a straight line. Hopefully you're shouting at the screen now what that is. So our total degrees is 180 degrees. So we know we are thinking about calculating angles on a straight line. And we already know quite a bit of information. We already know that one of the angles is 28 degrees. We know that a second angle, already known, is 49 degrees. And we actually already know a third angle, and that one is this 30 degrees here. And the final angle is our mystery one that we do not know, our A, as we've labelled here. So you probably can already start to see how you might find out the answer to this mystery angle. Unlike the first example, we don't have one figure to subtract from to find out that extra little bit that's left over. So the first step in this process is to find out what the total number of degrees we already know about before we work out what is left and what is missing. So to do this, you will need to do some calculating. So we're going to put our 28 degrees from up here, our 49 degrees plus our 30 degrees, which all together will give us 107 degrees. So we've already found our total there. So if we were looking at this, we've already identified that this is how many degrees we know about has been mentioned on our line, but we don't know this final part. And to find that out, as you did last time, we know our total, which is 180 degrees, and if we take away the 107 degrees that we already know, we are going to be left with what we are missing, and that is going to be 73 degrees. So now I can start putting in that information in order for us to find the answer to our question. So we know here that we've got our 73 degrees, with different colours there, and our 73 degrees here. And obviously we could easily check all of that by, well, how would we check it? Have a think. So I would shortcut here and I would just do my 107 plus my 73, knowing that that would then get me to my 180 degrees, which is the number of degrees in a angle on a straight line. So I know that by my checking that I have got the correct missing angle here. Okay, so we had a similar kind of question yesterday, but this time obviously our angle is all around this central point here. And I wonder if you can see if you can remember back to your time in junior school so far, and how many degrees does this whole turn, this full rotation turn, look like? And you might be able to remember how many degrees it has in it. Okay, so if you have remembered back, you will remember that a full turn, a full rotation, and how we describe this angle being a full rotation is 360 degrees. Now we can prove this because if we actually do divide up our circle into quarters, we can go back to that knowledge of our right angles, and we know that in our circle it is made up of 4 right angles, and we know, and should know by now, and you would have started to learn about in year 3, that that is 90 degrees. So each of the 90 degrees, 4 of them added together, will give us our 360 degree measurement, and it will give us our full rotation. So today, our 360 degrees is a really important number to hold on to when we're calculating missing angles around a point. So have that as your key bit of knowledge. Write that bit of knowledge down because it will help you in all your questions that you have today. Angles given, we have actually got 3 angles given, but we are still looking for one mystery angle here. So I won't slow us up because we already know the fact that the whole amount of degrees around a point is 360. We already know some of the mystery angles. We actually know 3 of them. We've got our 95 degrees here, our obtuse angle, just obtuse because it's just above 90 degrees, our right angle. We've got our 115 degrees angle, which is another obtuse angle, and we've got our 50 degree angle here that are known to us. So I wonder if you can remember back to what an angle is called that is below 90 degrees, below a right angle. It's got a particular name. In fact, you might just be able to spot some clues with the way that you can see it's kind of formed there. It's a little bit smaller than the 90. Forms a letter there. It's, yes, you're right, an acute angle, acute, to help you remember that one. And we have got that mystery angle here, E, that we are looking for. So once again, we're going to be doing our quick calculating. Obviously, you can take more time on these calculations, but this is what we are ultimately calculating and putting together. So we want to find out, firstly, what 95 degrees plus 115 degrees plus 50 degrees will be. So we've got our 260 degrees. So we already know, that's what that total is, already know. And you will surely be able to spot here between our 360 degrees and our 260 degrees, we've got another angle here. And hopefully, without us even having to calculate, but I will do so you can just see, you can see that if we did take away 260 from 360, so here's our calculation here, we will find that we have 100 degrees. So putting that back in our diagram, we can go back and we can put in that this will be 100 degrees here. And E on our diagram is 100 here. And then obviously we would want to go through and check that we have made all of these angles add up to our whole 360 degrees. So we've got our, or we can go through it in any order, but we can go for our highest number first, so that might help us a bit. Then we're going to add on our, let's go 100. And you already probably can see from place value what that next number would be totaling so far. And then we're going to add on, I would maybe go on to our 50, make it a bit easier, and then we're adding on our 95. And in total, that will get us back to our whole 360 degrees. So I know that I've checked that all of these angles are here, including our mystery angle that we've now found out will get us back to 360 degrees. You have an angles help sheet from yesterday, which reminds you about the fact that angles around a point, full rotation is exactly 360 degrees, which will be your key fact and key bits of knowledge for you to be successful today. So as soon as you've done your work, please send it through to your class teacher, and we'll look forward to hearing from you. Goodbye for now.